Hi, this is Xavier. Today we are going to discuss about refraction through a convex and concave. Okay. Already we have discussed about the special important cases, how to draw the ray diagram and how to follow the rules and regulation for the refraction through a convex and concave. Okay. First, listen here. This first we got to discuss about the refraction through a convex lens. Okay. So this is a structure. Okay, because this is a convex lens, the two surfaces are bulged out. It is a convex lens. Okay, can you understand? Already told you because the egg is the oval shape. Okay, because the two surfaces are very bulged out. Okay, so the center is very thick and the edge is very thinner. It is a converging lens also. We will get the image real and inverted. Okay, so first we have to discuss about the because the object is placed at a different located situation, so we have to get the different kind of image and the nature of the image. Okay, first is very important object position. What is the object position? Okay, for example, again I will draw the diagram. Okay, for example, is in here. This is a convex lens. Okay, this is a convex lens. This is a convex lens. O is the optic center. O is the optic center. This is the principal axis. F1 is the object and F2 is the image. Okay, so the C1, C2 is the center of curvature. C1, C2 is the center of curvature. Can you understand? For example, I already told you this is a again I will draw the diagram. Okay, this is a convex lens. This is a convex lens. Okay, O is the optic center. This is the principal axis. F1 is the object and F2 is the image. Okay, already we have discussed what is the focal length, the distance between the optic center and F1, because the F1 is the object. Okay, F1 is the object. F1 is the object and F2 is the image. F2 is the image. So we will get the image real and inverted image. What is the real and inverted image? Real and inverted image. Okay. The object is always placed on the left side. These are rules. Okay, sign convention rule. Okay. So the object is always placed on the left side. The image will appear on the right side. The image will appear on the right side. Okay. So you know that what is the focal length? The distance between the optic center and the F1. Okay. So it is called as a F1. This is a F2. Okay. So again, it is a U is the object distance. U is the object distance. V is the image distance. V is the images. Okay. For example, the image. Okay. The object distance will be decreases. Image distance will be increases. For example, you have kept the lens on the center in the middle point. So you have to place the object on the left side. So the object is very closer to the lens. Okay, but the image will be appear on the right side. So we will get the image real and inverted. But the size of the image and the nature of the image is very important. Okay, the object is very closer to the lens. So the object distance is decreases. The image distance will be increases. Can you understand? நான் சொல்றது புரியுதுங்களா? நம்ம வந்து ஒரு லென்ஸை நம்ம சென்டரில் வைக்கும்போது ஒரு லென்ஸை சென்டரில் பேஸ் பண்ணியிருக்கோம். அப்போ லென்ஸ் என்னது, ஆல் த டிஸ்டன்ஸ் ஆர் மெஷர்டு ஃப்ரம் த ஆப்டிக் சென்டர். லென்ஸோட சென்டர் பாயிண்ட் தான், மைய பகுதி தான் நம்ம என்ன சொல்லுவோம்னா ஆப்டிக் சென்டர். ஓகே, அப்போ நம்ம ஆப்ஜெக்ட் வந்து லெஃப்ட் சைடில் பேஸ் பண்ணும்போது இந்த ஆப்ஜெக்ட் டிஸ்டன்ஸ் இஸ் டிக்ரீசஸ், இந்த இமேஜ் டிஸ்டன்ஸ் வில் பி இன்க்ரீசஸ். அப்போ அந்த ஆப்ஜெக்ட் டிஸ்டன்ஸ் வந்து கொஞ்சம் கொஞ்சமாக ஸ்டெப் பை ஸ்டெப்பாக நமக்கு வந்து டிக்ரீஸ் ஆகும்போது நமக்கு இமேஜ் டிஸ்டன்ஸ் என்ன ஆகுது, இன்க்ரீஸ் ஆகுது. ஓகேவா, இதுதான் நம்ம மெயினாக பார்க்க வேண்டியது. ஓகேவா, அப்போ நமக்கு கிடைக்கிற இமேஜ் எப்படி இருக்கும், பெருசாக இருக்கும். இட்ஸ் ஏ வெரி பிக்கர் இமேஜ் ஆர் என்லார்ஜ் இமேஜ். ஓகே, அதான் நம்ம பார்க்க போகிறோம். ஓகே, ஃபர்ஸ்ட் ஓகே, கேன் யூ அண்டர்ஸ்டாண்ட் திஸ் இஸ் இம்பார்ட்டன்ட் கேசஸ். ஓகே, ஃபர்ஸ்ட் வி ஹேவ் டு ட்ரா த டயக்ராம். ஓகே, first the object placed at, okay, the object position, image position, size of the image, nature of the image. There are 4 cases are very important to study about the refraction through a convex and concave. Okay, first the object position at infinity. The object position at infinity. Okay, the object position at infinity. The image position. Okay, only we have to find out the image position. Okay, so image position at f2. Okay, the image position at f2. The size of the image is the diminished. Okay, the size of the image is the diminished size. Okay, diminished. The size of the image is the diminished or point size. Okay, diminished or point size. Diminished or point size. The nature of the image you know very well. So we have to get the image real and inverted. Okay, real and inverted image. So we have written the condition. After that we have to draw the diagram by using this method. Okay. So listen here. First we have to draw the diagram. Okay, this is a basic structure. Okay, for example, okay, the object page. Okay, for example, what is the type of lens? This is a convex lens. This is a convex lens. O is the optic center. This is the principal axis. F1 is the object and F2 is the image. Okay, and C1, C2 is the center of curvature. Okay, listen here. The object position. Because the object is always placed on the left side, so the object placed at the is very farthest distance at the infinity. Okay, so the object placed at the, listen here, the object placed at the infinity, object placed at the infinity distance, object placed at the infinity. Okay, infinity. What is the meaning of infinity? It's a very farthest distance. Okay, it's very longest or farthest distance. Okay, okay, listen here. So we know that the light ray travel. What are the medium? What are the medium? We know that the medium. There are two types of medium. Okay, there are two types of medium. One is the denser medium. Okay, one is the denser medium. Okay, denser medium, and another one is the rarer medium. Denser medium and rarer medium. What is the denser medium? The denser medium is the solid and liquid. Okay, solid and liquid. The denser medium is the solid and liquid. Okay, solid and liquid. What is the rare medium? Rare medium only is the gas is the air medium. It is an example for the air medium. Okay, I understand. So you have to differentiate. So we have to differentiate by using the formula, density formula. Density equal to mass by volume. So you have to cross multiply the value m equal to 0. Okay, why we have discussed about it? Because the light ray can travel through the rare medium to the denser medium. Okay, for example, in your physics Guruji has given an instruction with you. If you consider the fish tongue, so you got to pass the light ray. And the light ray travel air medium into the water. So the light ray will be bending. For example, you got to do the working experiment. Okay, you have to take the laser light. You got to pass the light ray. So the light ray can travel air medium into the watery medium, because the air is the rare medium, water is the denser medium. So the light ray can travel through the first medium to the second medium. Okay, the first medium is the air. So the light ray can travel straight line, but the light ray can travel into the second medium into the water. The water is the denser medium. So at the time we go to see the image accurately, because the light ray will be bending. Okay, light ray will be bending. Okay. So listen here. The object placed on the left side at infinity distance. So the light ray travel from rare medium to denser medium, rare medium to denser medium. So we know the light ray light is always traveling in a straight line. Okay, light is always traveling in a straight line. So this is a path of light. Okay, we know that the path of light is also called as a ray of light. Group of light is also called as a beam of light. The source of light is called as a luminescent object. Example: sun, stars, and a candle. Okay, luminescent object. Okay. So the light ray will be travel through the travel from rare medium to denser medium. So the light ray will be bending. Light ray will be bending. So the bending of light ray will be converging at F2. Converging at F2. Okay. And another light next to this. Okay, this is the first light ray. The another light ray will be travel through the optic center without the deviation. Okay, the light ray can travel through the optic center. Okay, without the deviation. Without the deviation. Okay, without the deviation. So we will get the image written here. We will get the image. For example, this is a A to B. This is a A to B. This is a B dash to A dash. B dash to A dash. This is a real and inverted image. Okay, real and inverted image. Real and inverted image. Real and inverted image. Okay, real and inverted image. So we have to write the condition. The object position at infinity. The object position at infinity. Okay. The object position at infinity, the image position at F2, the size of the image diminished or point size, the nature of the image real and inverted. This is the first diagram. Next you have to write the second condition, and the object position at beyond C1. What is the beyond C1? Okay, so we will get the image between. We will get the image between. We will get the image between F2 and C2. F2 and C2. The size of the image is a smaller size. Okay, the size of the image is a smaller size. So the nature of the image is the real and inverted. Real and inverted image. Real and inverted image. Okay. So we got to draw the diagram. For example, this is a convex lens. Okay. For example, this is a convex lens. Okay. This is a convex lens. This is a convex lens. O is the optic center. This is the principal axis. F1 is the object and F2 is the image. And the C1, C2 is the center of curvature. So now it placed on the left side. Okay. So now it placed beyond C1. Okay. Now it placed beyond C1. So the light ray traveled from rare medium to density medium. Rare medium to density medium. This is a path of light. So the light ray will be bending. Okay, can you understand? Because the light ray can travel from the rare medium to density medium. So immediately the light ray will be bending. Light ray will be bending. So the bending of light ray will be converging between F2 and C2. Okay. Another light ray will be traveled through the optic center without deviation. Okay. Another light ray will be traveled through the optic center without the deviation. Okay, so we got to see the image. We got to see the image between B dash and A dash, between C2 and F2. This is A and B. Okay, I understand. So we will get the image real and inverted. What is a real and inverted image? Okay. Next we have to draw the diagram. Okay, so there is a second case will be completed. So we have to write the third case. Now object placed at C1. So the image position at C2. The size of the image is the same size because now object placed at C1. So we will get the object placed at C1. The image we will get the image at C2 because both are the same distance. Okay, focal. Okay. So same size of the image. So we will get the image real and inverted image. Real and inverted image. Okay. So we have to draw the diagram. For example, this is a convex lens. Okay. This is a convex lens. O is the optic center. This is the principal axis. F1 is the object and F2 is the image. Okay. So the C1, C2 is the center of curvature. Okay. So the object placed at C1. Okay. So this AB is the object. So the light ray travel from rare medium to density medium. So the light ray will be falling on the lens. Again the light ray will be bending. The bending of light ray will be converging. The bending of light ray will be converging at C2. And another light ray will be traveled through the optic center without the deviation. Light ray travel through the optic center without the deviation. It is a path of light. Okay, this is a path of light. So you have to write the condition. So the object placed at C1, the image position at C2. The size of the image is the same size. The nature of the image is the real and inverted. Okay. Next, fourth case. An object placed between C1 and F1. An object placed between C1 and F1. So we got to get the image beyond C2. What is the beyond C2? The size of the image is a larger size. Okay, now because the object distance will be decreases. Okay, the object distance will be decreases. Image distance will be increases. Okay, so we'll get the size of the image is larger. So the nature of the image is the same. Real and inverted image. Okay, so we have to draw the diagram. This is a convex lens. O is the optic center. This is the principal axis. F1 is the object and F2 is the image. The C1, C2 is the center of curvature. So now object placed between C1 and F1. F1. So the light ray, listen here. So the light ray travel from rare medium to density medium. So the light ray will be bending. The bending of light ray is also called as a refraction. Okay. So the bending of light ray is in here. The bending of light ray will be converging. The bending of light ray will be converging beyond C2. Okay, beyond C2. Okay. And another light ray will be traveled through the optic center without the deviation. Another light ray will be traveled through the optic center without the deviation. without the deviation, without the deviation. So we will get the image B dash to A dash. AB is the object. AB is the object. Okay. AB is the object. So this is a condition. Okay. Next, and the object position. The object placed at F1. The object placed at F1. So the image position at F2. Okay. So we have the size of the image is a very enlarged size of the image. Enlarged size of the image. The nature of the image is the real and inverted. What is the real and inverted image? Real and inverted image. Okay. So we have to draw the diagram. For example, this is a convex lens. The convex lens O is the optic center. This is the principal axis. F1 is the object and F2 is the image. And C1, C2 is the center of curvature. C1, C2 is the center of curvature. So the object placed at F1, AB is the object. AB is the object. So the light ray traveled from rare medium to denser medium. So the light ray will be bending. The bending of light ray will be converging at F2 because the convex lens is a converging lens. Okay. The another light ray will be traveled through the optic center without a deviation. If anyone say the answer, because this is the fifth condition, because the object position at F1, the image, so we will get the image at F2, so you have to get the size of the image, is the enlarged image, the nature of the image, real and inverted. But in this diagram, listen here, but the two, you have to look at the diagram, okay, because the two light rays will be converging, so we will get the image, okay, first, second, third and fourth diagram, but the fifth diagram, the two light rays will not be converging because the two light rays are travel the parallel direction, okay. So you have to get the very enlarged size of the image. Okay. Last final statement. Listen here. The object placed between F1 and O. Okay, between F1 and O. So we have to image position at C1. So image position. So the image position at C2. Okay, the image position at C1. Image position at C2. Okay, so the size of the image is it's very bigger than that of the object. The last final statement. So we will get the nature of the image is the virtual and erect image. Okay, because of listen here. For example, this is a this is a convex lens. Okay, convex lens. Okay, O is the optic center. This is the principal axis. F1 is the object and F2 is the image. And C1, C2 is the center of curvature. So the object placed between F1 and O. This is A and B object. Okay. So the light ray travel from rare medium to denser medium. So the light ray will be bending. The bending of light ray will be converging. Okay, bending of light ray will be converging at C2. Okay, the bending of light ray will be converging at C2. And another light ray will be traveled through the optic center without a deviation. But the two light rays will not be converging. Because the two light rays will be traveling the parallel direction. So we have to get the image on the same side on the left side. We know that because it will be acting like a concave lens. Okay, so the image is in here. The object and image, okay, object and image, both are the left side, okay, both are the same side, left side. So it will be, listen here, it will be bounced back to the same side, okay, because it appears to, okay, listen here, it appears to diverge from, okay, this is A dash, this is a B dash, because we will get the image, okay, because the right side, listen here, see, very important condition. The object is always placed on the left side, the image will appear on the right side, so we will get the image real and inverted. The image appear on the right side, but the image will be appear on the left side. We will get the image virtual and erect. What is the meaning of virtual and erect? It is a shadow. Okay, so virtual and erect image. What is the virtual and erect image? Okay, virtual and erect image. It appears, listen here, it appears to diverge from the left side, appears to diverge on the left side. Okay, this is the condition. I hope you understand about this topic. Next class we will discuss about the another interesting topic. Okay, thank you so much.